What is the idea behind mechanical sympathy? Well, the mechanical sympathy is a concept in software engineering that refers to the practice of understanding the underlying physical characteristics and constraint of a system in order to design software that is well suited to the hardware on which it runs. The goal of mechanical sympathy is to create software that is in harmony with the hardware it runs on, rather than fighting against it. So it says that software should be designed to take advantage of the specific characteristics of the hardware rather than trying to abstract away those details. And by understanding how the hardware works, software developers can create algorithms and data structures that are more efficient and can make better use of the available resources. Those who propagated this idea, Martin Thompson and Dave Farley, it is said that they were inspired by the Formula One racing driver Jackie Stewart and his popular quotation where he said, "You don't have to be an engineer to be a racing driver, but you do have to have mechanical sympathy." Understanding how a car works will make you a better driver. And it has been argued that this is analogous to programmers understanding how computer hardware works. You don't necessarily need a degree in computer science or be a hardware engineer, but you do need to understand how hardware works. And that take into consideration when you design the software. So as we know that already the days of architects sitting in ivory towers and drawing UML diagrams are over. Architects and developers must continue to develop practical and operational experience from working with the new technologies, and they must work together. So, in a more practical terms, we can say that mechanical sympathy is about creating algorithms that are optimized for specific types of hardware, designing the data structures that are cache friendly to minimize the number of cache misses and improve performance, taking care of CPU cycles, avoiding using busy waiting and polling because it consumes more CPU cycles, designing systems that can adapt to changes in the hardware environment, such as scaling up or down to take advantage of changes in the number of available CPU cores, or tuning the software to the specific characteristics of the hardware it runs on, such as adjusting the garbage collector for the memory hierarchy of the target system. In a nutshell, having some mechanical sympathy with your hardware can help you to improve the performance, scalability, reliability, maintainability, and understandability of the software too, which will reflect in the overall quality of the system that you design.